give everyone a warm welcome. Thank you for being here in this workshop on no-code test automation. In particular, we're going to see how to do visual testing on a low-code, on an enterprise scenario. Can someone just confirm, Osama, that the screen sharing is working?
Yes, it's working, yes.
Just to be safe. So hi, everyone. I'm Lucas, the founder of Logicflow, and we're developing visual testing and maintenance, like AI for end-to-end test maintenance with a platform called Astra. And today we're more going to look into the machine learning concepts on how to eliminate weights. Weights are often a big challenge in Selenium scripts in particular. We'll see how visual weighting mechanism removes the need of weight engineering. We'll show some maintenance examples of how we eliminate selector engineering with machine learning, and how we eliminate the need for asserting individual elements on the page by just simply asserting an entire portion of a screenshot. And we'll show how this overall leads to minimized maintenance for end-to-end test case scenarios. So what do we expect from progress in low-code engineering on the end-to-end testing side? We expect to be able to create tests, end-to-end tests in a no-code fashion, meaning we don't need to write any code, or in the low-code fashion if we just need to extend for certain custom or application-specific scenarios. We expect not to have to do any weight engineering, so the weighting mechanism should just be autonomous. We expect to be easily able to assert entire portions of a screenshot to visual assertions, just like a human tester, a human QA engineer would, or quality assurance person would look at the screen and see a bug. Not only assert the text, but as well be able to assert the layout and color and all these non-functional aspects. And as long as the workflow didn't change entirely, we expect the end-to-end scenario just to run through independently of changes in the code structure or code framework used to implement a certain application. So yeah, what's the objective of low-code test engineering is to have a low-code test tool that can reduce the effort to create accurate production scenarios, but nonetheless produces like human readable and maintainable scripts in a UI format or in a coded format. And the goal of them is to automate test scenarios for the application under test, while maximizing the assertion coverage and minimizing the maintenance effort. And we want to do this with the least amount of effort possible. And how does this look nowadays? If we hand code it in Selenium, we start writing a script like we can see here on the right. In this case, it's Selenium with C#, and we start writing code to open the page, assert certain elements on the page. Then we'll have some weight engineering. If the page is slow to load, we need to make sure that the page is fully loaded before starting to check. Then for all the different elements, we need to start finding the correct selectors that will be robust when the application changes. Ideally, there are good technical IDs, but technical IDs are not always available, in particular when working with third-party applications. Then the assertion engineering ends up in particular when, for example, asserting your table with like full name, email, company name, it starts being a lot of code to assert that we're looking at the right row with the right content. This adds a lot of code to maintain later on. And the more code we have in the script, the harder it becomes to maintain over time. And this is really the core goal, is to reduce this script, to make all the code engineering that we put into automating such a scenario to minimize this, then to repeat in For the weight engineering, instead of creating like custom weight loops for every step, we just have a generic computer vision algorithm that monitors the page readiness autonomously, just like a human would look at the application and wait for the entire screen to be rendered. We don't write a lot of assertions for individual table cells and so on, but we assert the entire part of the screen that needs to be asserted. The recorder automatically tracks all the information needed to identify an element of the page, just like a human tester would do it, and would look by the size of the button and layout and text content, and would figure things out if the button maybe is renamed or moved to a different location on the page. And last but not least, and for the maintenance, that's the maintenance part, is that the algorithm resolves like changes of elements by itself. So that's is it worth a try? So there's already a number of tools available, but we believe that yes, the future is to be low-code approach that will support eliminating all these redundant test tasks an engineer would otherwise spend time on, and that would be a significant improvement in speeding up quality at the end-to-end testing level of an application development. So now let's get to the first part of the workshop, in particular the weight mechanism. So I'll briefly explain how it works, and then we will jump to the application, and I will be sharing the link where you can open the tool itself, and you can follow, or you can just watch me presenting the use cases, or you can then do the workshop exercises yourself at the same time. So how does the tool work? It's a virtualized recording environment, meaning the Selenium in the browser session are opened on a virtual machine in the cloud, and all the actions during recording are already executed through Selenium at recording time, which guarantees almost to 100% the replayability of what was recorded. And the weighting mechanism uses a neural network to monitor in real time the page readiness of the browser. So what's happening, and it's shown here on the diagram in the right, we have like a reference screenshot comes from the recording and a reference DOM snapshot. And while the page is loading, we continuously take the screenshot and compare it. The neural network compares it to this reference and just outputs if the page is stable or not. And this is done in about 40 milliseconds intervals. So it's fairly fast at determining the page readiness. So the example that we're going to look at is a e-banking demo that is publicly available. And on clicking the login, passing the login screen, there's a page loading at the center, and we'll show how the visual weight can properly wait for the page to be fully rendered. So for those who would like to do the use cases at the same time, you can open the link here on astra.logicflow.ai or use the QR code here. I will wait 30 seconds before jumping to the exercise. Then let's get to it. I will change here to, I already pre-prepared everything to go to here, and we're going to do this again. So here I will start up with the visual weight demo. So it's a very short scenario. We're just going to open this e-banking. So maybe yes, could briefly introduce the tooling, what we're looking at here. So this is Astra. Here on top, we have the project name. Below the project are all the recorded test cases. And for each test, when selecting a test here below, one can see the executions of a given test case. But we're going to go through all of this in a minute from scratch. So I'm just giving a quick overview. And for each test case here, we can see the actions. And to the right, we can see the details with the screenshot. And we can see, for example, all the DOM snapshots that are available in the screenshot. And we can browse through the scenario here, clicking through the steps. So here we're just opening this demo, and there's this first page here that has an interesting waiting need for the page to be fully rendered. For example, here in the recording, this is how the page looks being rendered. And if we, without wait, the page would be in such an intermediate stage, which is not suitable to assert now anything visually. And with a proper wait mechanism, we'll see we can visually wait for this to be ready. For those following the workshop from scratch, you will be arriving on a starting page looking like this. You can click the new project button and create the new project, for example, Live2Test and your name maybe. And once you click save, you will arrive on a blank project where you can follow what I will be doing. So to reproduce here this visual wait demo, we'll start here is the recording button in red. We'll just start a new recording. We'll call it visual wait demo live. And we just hit start. And we're going to open, so here I already have this page ready. I will be copy pasting, if you like, this into the chat. Here's the URL. And now we're just going to open the main page, and we see there's some loading going on. And now we will jump to another page. For example, we want to start making a payment, for example. And I will just stop the recording here. So now we click, this is the new test that we just recorded, wait demo live. It has 6 steps, and we have this opening screen. And we're going to now see what happens when we replay it once. So we're going to replay this baseline here once. And I don't have control over this application, so I cannot guarantee the loading screenshot, but we'll see in a minute what happens when we activate the visual waiting mechanism. So yes, so as expected here on the opening, without the visual wait, the scenario just waits for this button here to be ready and then keeps going as fast as possible. And here we can now introduce a first checkpoint. So waiting for the page to be entirely ready is only necessary when we want to compare a screenshot visually. So here we can now activate this checkpoint. And what does a checkpoint do? So the checkpoint here will really assert every element on the page and check that the application is unchanged compared to the reference recording we did. And if I now replay this again with the checkpoint included, we can see that it properly waited for the page to be ready, and we can actually even measure here quite precisely. It took around 2 seconds until the page was exactly ready, and there was no, so here we have the baseline. This was the recording we just did, and here's the current result, and it's identical, there's no changes. Maybe to show here as well, when I reload, there's this loading animation here. There's really a number of dynamic elements to wait for to get a good comparison. So that covers the first part here of the autonomous waiting example. So that's what machine learning can do in terms of visually monitoring the page readiness and really get this exact screenshot stages, time exactly when to perform the next action. And it's a requirement, really an important one, to then properly do computer vision on the screenshots to find bugs, because the page needs to be ready. One cannot find bugs if the page is only partially rendered. So now we will get to the next part, which is the autonomous maintenance part. To give a bit of background on the theory, what does the machine learning algorithm on the autonomous maintenance do? It from the recording, it has the reference element on the page. So I can, for example, on any step here, for example, this pressing this payment button, we track the visual aspect in the screenshot, the bounding box here, the location and size, and the text inside, various style properties, and all of these properties that are tracked on the reference element. If this element is not found exactly with like standard selectors in the page, because maybe between two releases the development team changed the HTML structure in the classes, and maybe there's no technical ID to identify it uniquely on the page, the algorithm will take a snapshot of all the candidate elements on the page, which is the same than what we can see here. Like we can see we have the entire snapshot of all the DOM elements, and it fetches them, and then it runs the machine learning algorithm of determining which elements. So for each element, candidate element, it will compute the probability that this matches the reference element, and then one can rank the matches by probability and take the highest probability element on the page. And when there's no good element found, when the algorithm can as well decide to skip or eventually introduce an additional step. So additional steps are, for example, with accept buttons or terms and condition pop-ups that only appear conditionally. These sort of scenarios can be handled. So we have a to-do here for the workshop. We have a to-do application to demo this. So we will show in a second of a standard to-do app on the left here, which has like all active completed buttons here in the button in the menu at the bottom. And we made a completely modified version here on the right, which we renamed everything to German. We don't have any technical IDs on the elements, and the texts are translated. We renamed the CSS classes, and we even changed all the DOM structure and tags. So it's a very hard scenario if a Selenium selector would not work anymore to identify these elements. But the machine learning algorithm going visually inside the screenshot will find and identify the correct element. To show the changes in detail, I will open. So we have here, I'll post this in the app in the chat as well for those who want to do the workshop exercise. We have the to-do app, and I can show here the HTML structure. So here in this case, we have like on the reference application a list with li elements for those who know with the HTML structure, and link inside. There's only a class filters available. And on the modified application, show the structure as well. We have like a footer with divs, so no list, no li elements. We have spans instead. And we renamed the classes as well, have been renamed. So there's all the modification of the structure that's been made. So here we're gonna get to this maintenance scenario. That's the pre-recorded one, just to show what we're going to do. We're just going to open the standard to-do app. I'm gonna add an item and see the active items, see once the completed items, then clear the completed items, delete an item eventually, and then we'll stop the scenario there. And then we'll show how the maintenance works. So I will start a new recording. I'll make the screenshots here very small, then it will be easier to see. we'll open the standard to-do app. So you can copy paste the URL into the address bar. Open this one item. So we're going to go to active, completed, clear. Eventually delete this last item again. And that's going to be our scenario. And I will add, for example, one checkpoint here after on the fourth step, I will add a checkpoint to check that here this item has been added. If we now replay this scenario, just with no changes at all. So here we see that the scenario is green. There's no visual changes, completely identical. And now we're gonna, so imagine this is your release A, and now we're going to have the modified version. Let's assume that's the next release B. And we're just gonna make one tweak here on step 6 when clearing the completed items. We're going to mark this as an optional step so that we already allow this to be skipped. Paste here as well. This is the second link where we're gonna open, and we're going to replay this. So in here on the replay, we can see a number of things that happen. Or the test case failed, because on the checkpoint part here, it correctly did the comparison and found the title here was changed. It found all the renamed buttons in the menu at the bottom in the footer, and it found the missing button. So here we didn't have to do any explicit coded assertions. We just had to activate the checkpoint, and then the machine learning computer vision algorithm automatically found all the modified elements by itself. And we can see a number of other things. Is these icons here show that there was an automatic maintenance that the machine learning algorithm had to find the correct element in the screenshot, and so it correctly found the active button and the completed button. And here it decided then to skip this step that's no longer available. And so this is how the maintenance is automated, and one can very easily find all the changes in a given checkpoint. And so let's say this is the correct. So how do we do the maintenance to make this the correct reference again? We can just upgrade this run to be the new baseline. So we'll maybe, for clarity, rename this. This is release 1, and we'll call this maybe our release 2. And so let's say this is our new release, and we approve all the changes that have been found there. They're correct. That was like expected as it is. If we now replay against the new baseline here, which is created for the release 2, the test case will be green again. Here the run is true, the comparison was made against the new baseline, and all the changes there's no more changes against this baseline, and everything is green again. So this is how we can do the maintenance with a few clicks, and we didn't have to modify any of the code to assert any of the button. If we now had like classical assertions of the text content, we would have to go into the code and change all the text that we are asserting in these buttons. But because it's done visually, we just need to approve the new baseline, and that's it for the maintenance. So much for the maintenance part. I already went a bit ahead and showed already a visual assertion. So we had the checkpoint system. So here's like to show on the left, we would be having a lot of code to assert all the different elements on a page. And with a visual assertion, we just have like a single line to take a snapshot and assert the snapshot on maybe an initial page, and then assert the snapshot again on a new page, which here's for a search scenario in a customer relationship management tool, which is the last scenario that we're going to be doing today. But so sometimes there's dynamic elements on the page that we don't necessarily want to check, or that could cause a lot of false positives. And we're going to see now how to specifically assert certain parts of the page, or exclude some other parts of the page. So we'll get back to this scenario here and say, for example, there's two variations. We can say we want to just assert a specific part of the page on the screenshot. So we can just add this here by annotations. So right-clicking on the menu here, we can add various annotations on the screenshot. And in this case, we're going to use a visual assertion, and we'll check item is added. And we want to fail the scenario when something changed, but at the same time, we want to still continue the execution on the next steps. Now what's happening here is that this is a checkpoint, but we will only be asserting that one element on the page. So here we see, despite the changes in the button, this part of the screenshot here was not changed, and here this assertion that we added on the item was passed successfully. But this can be very convenient to only check for certain areas in the screen. Another option, I will not delete this assertion again, would be to exclude certain areas. Maybe there's some login times or so that we don't want to check. And here we're going to exclude the title, and we're going to use here the visual exclude of the menu as well. But we want to assert, so now everything on the page is going to be asserted, but we will exclude these two parts. And here we get the same effect, that this test case is passing because it's ignoring these areas which have changes. You can see that there's no changes, and here we can also see that the two excluded parts were successful. So much to the examples, the dummy examples with the to-do about the maintenance and the various ways to use visual assertions to check the relevant parts of a page. And now we're going to put all of this together on a scenario on Microsoft Dynamics. It's like in that case, it's a marketing tool. And we'll, for example, assume that maybe there's a custom implemented contact list, maybe with some external systems that provide the data, and that's why there's a monitoring test case needed to check that all the systems are correctly working and connected. And we want to search for a contact that first doesn't exist, then create it, then go back to the list, check that we found it and found that new contact, and then delete it again. So that's why here a screenshot of Microsoft Dynamics contact list, and we're going to be automating the scenario on this. And we can then add, for example, visual assertions on the menu bar to check that the test user we're using has all the correct access rights, and this would then be triggered in case of any change in the permissions or menu options that are available. And it's very convenient to keep a detailed track of any changes of permission or configuration that happened in the system. Go back to the application, so there's going to be slightly right for the clicking here on the dynamic scenario. I will show the scenario once ahead. So first we're going to go through a login, and once we're logged in here, we will go to the page and search for a certain user, for John Doe, which doesn't exist. We'll check that user was indeed not found, and we'll go and create it. Here I put in the first name and last name, and we're going to go and save that user, get back to the page. We'll clear once the search, and then execute the search again. We'll check that we found exactly this user, and then we use the visual assert to assert the search results. And to make sure that the scenario can be executed multiple times, we then go ahead and delete this user, this contact again from the list. We report the scenario to show the live demo and how we have built it originally. So we'll start a new recording. So unfortunately, I cannot share the login data for this part of the workshop. We'll be logging in with a logical test user. Let's go through the login. We don't need to stay signed in. Go to the marketing. All right, so here we're now on the starting page of Microsoft Dynamics marketing, and we'll go into the audience, into the contact list. Perform the search. And we'll see that the user is not found, so we're going to go ahead and create one. Save and close creation screen. Now we're going to clear the search. Perform the search again. See that indeed we have that one expected result, and so to be able to reproduce the test case, we're going to go ahead and delete it again. that's the scenario we're going to be working on. So I will stop the recording here. We can see the login. So login is often something that we want to be doing multiple times. So I will go actually find the first screen we here up to the marketing part. So this is a login we might want to be reusing quite in a number of different scenarios. So here after the recording, we can create like a comment on how this login live, which we replace in the scenario. So now we created the login comment, so to avoid having to repeat these steps, for example, in new scenarios at every recording, and we have these commands here documented that just perform the login steps, and this could be re-executed during a new recording to speed up the process. And now we're going to go through the rest of the scenario, which is actually the relevant part for this scenario. So we're going to go here. We searched for the John Doe, and here we want to check that there's no result at this step. So we would activate this as a checkpoint. We would just go for a visual assert and check not found. It would be the first checkpoint. And we keep going on the creation, and here we are resetting the search, and so we will only check after the search being performed again. So here after the search being performed, we want to check, we'll do another checkpoint and check that indeed the user was contact was found. And this is going to be our scenario to check here that the contact search with like maybe an external system providing data is correctly working. And in the scheduling tab in monitoring, one could easily set up a schedule to run this in, for example, every half an hour to check in real time that the system is up and running. Now we're going to replay this. And in the next step, we're going to see how it's possible to maintain, for example, if there's a test environment and a production environment, and we need to maintain different baselines because there's different test data in this, or there's test data in the test system, and maybe a production data in the production system, how we can deal with these cases in a visual testing fashion. Now the scenario is passing here on the step 5. The contact was not found, and here after creating it John Doe was found in the scenario screen, and we could be now within 30 seconds create a schedule to run this every half an hour on a system of your choice. So now to make sure that the assertions work correctly, we're going to parameterize the test case and rerun this with modified data. Here we'll pop out the action list, and we're going to go through the individual steps. So here we will call this this is our search. Maybe we'll do a variation on the first name. This is the first name, the last name. So here we're providing keys that are going to be used to provide various inputs to these exact fields. And we're actually going to disable to make this more clean. We'll only provide inputs on these fields. So now to rerun this with different parameters, we create a parameter set, and I will create one called Richard Doll the second. I use the test scenario that we just recorded. We have all the variables that we can overwrite. Here we have Doll, but now we don't want to call it John, but we'll call that user Richard. And here we'll have this data, and we just modified the first name of the user we're creating. Oh, here we have our test data now that is ready for usage, and we can replay this with this parameter set. So we're gonna use this one with Richard here. And this is going to trigger the second checkpoint where we have the user in the search results, and we'll trigger a failure. And now as expected here, the first checkpoint, there's no data available. That's fine, that's passed. But the second one here now triggered because the first name here was changed to Richard the second. Now let's assume that this is maybe our that's the first environment. And now we will have, this is a second environment. Now we can promote this replay, we can promote it to a baseline, and we can have two different baselines to be used on the different environments, which will allow the visual check to pass on each environment against the correct baseline. And we can, for example, to monitor two different environments, create two different schedules with the matching baseline for the environment that one wants to test. Now this replace, I can discuss some more use cases. For example, now here we just asserted that there's no user, but as mentioned previously, if no one wants to assert, for example, different permissions in the menus, different user roles should be having different permissions of what they can do with the contacts. Maybe some users are allowed to edit, some are only allowed to view. We want to check what's in the menu of a given test user. And here it becomes very simple. We just check the menu entries. And now I would assert here this entire menu bar, and if there's any added or removed functionality, this would trigger as well. And with the parameterization, we can execute, for example, a loop over different test users that were for the different roles that need to be checked. Now the run that we had here is now passed. So for environment 2, when we see that with the correct baseline, it will do the comparison against the correct name in the baseline, and then the visual assertion will be passed. So in summary, a no-code approach has much less code to maintain. Here in this case, none. It can always be combined with hand-coded scenarios, for example, for maybe there's in the login two-factor authentication or so that needs to be handled with an API call, or there's some CAPTCHA that needs to be handled. One can combine like coded snippets with the no-code recordings. The maintenance is much reduced due to the AI-driven maintenance that automates all the common cases of modifications of just the DOM structure in a web application. The execution is fast despite scattering all the screenshots and DOM. The visual stability check that we've seen allows to make sure that really all the elements are properly loaded and already when there's animation properly rendered, which is needed to assert like visually what's on the page. Well, we see that we have like an increased coverage. It's much easier to really track all the changes, not just the text in the button, but as well its location, layout, and style. Maybe two buttons after some CSS change, they are overlapping, which is not good for usability. But this could go unnoticed in a classical script, but visually this doesn't escape. We'll see, yes, one point that we didn't see is the collaboration aspect. So having everything visually, let's assume we have this. Let me go back. I will use this one. We'll just assume that, for example, this case here, let's say this was a bug. There was really the wrong data shown in the system, and we now wanted to create a ticket to share. It's very easy to create a link and just send the link to the development team that needs to look into it. And with this link, they arrive directly on the right page with the right context, and they can browse everything step by step to understand what happened. So that makes the whole collaboration flow between testing teams and development operations and application teams much easier. And this we're not going to cover in this workshop, but it is straightforward to integrate scenarios into a CI/CD to run them, for example, in automated fashion for regression testing in a continuous integration pipeline. So overall, we'll say the objectives are achieved. We didn't have to do any weight engineering here on the e-banking demo as a real e-banking application, and customer relationship management tool for Microsoft like MS Dynamics. Despite longer waits on or loading times on opening and transitioning between pages, everything worked smoothly without having to do anything. We didn't have to go and assert various texts in the app. We can just very quickly assert the correct part in the screenshot. We didn't have to generate any repetitive code or no code at all. And even when the application changes, it just runs through, and we didn't have any maintenance effort. So this concludes the end of writing test code. No, there's still always a lot of custom needs in every enterprise application landscape that need to be being addressed with custom code, but no-code approach and low-code approach like greatly reduces the effort needed to automate all the scenario. So I hope you enjoyed the workshop, and thank you a lot for attending.